Okay, I'm back to finish this. So this is the long answer, and I think there's like only three, so one SL, probably two HL. Yeah, so once this is done, then that's everything. And then I guess I'll go over the SL level papers, at least the questions that I didn't already go over in the HL papers. Okay, so here's a classic paper 2 question. We have the like a trig graph. So here is the height of water somewhere. And then we need to find the length of time between the first low tide. Wait, the length of time between the first low tide and the first high tide is 6 hours and m minutes. So here's our first low tide, right? And here is our first high tide. And they're saying that this is 6 hours and m minutes. And then we need to find m. So one thing to note about waves is the time between the minimum and the maximum, or vice versa. This is always going to be half of your period. That means that your full period will double. In other words, it's 12 hours and 2m minutes. Yeah. Okay. Now, we know exactly how long the period is because we have the equation of the height of the water. So there are four constants and coefficients. There's A, there's B, there's C, and D. And they all do something or are related to something in this wave. However, we're really only interested in B. So B is related to the period. And we know that the period of sine is normally 2 pi. It's a full circle. However, B is a function transformation. It's a horizontal compression. So the period of the compressed wave is the original period, 2 pi, divided by the value of B. So we can put this into a calculator, and then we can solve for m this way. Where's my calculator? Hello? Get me out of here. Okay. So 2 pi divided by B. So we know that our period is 12.2479 hours. Okay. Now, the hours are gonna match, right? So this means that 2m minutes is the same as 0.279 hours. In other words, right, if we take 2m and then if we divide this by 60, because there's 60 minutes in an hour, this fraction should be the decimal part of the period we calculated from using B. So from there, we can just multiply this by 60 and then divide by 2. So let me take off the 12 hours, multiply this by 60. So the period is like 12 hours and almost 15 minutes. So this is 2m. Divide this by 2. So m is like 7. I think it says to the nearest integer. So we are going to round this down to 7. Okay. Between two consecutive high tides, determine the length of time in hours for which the height of the water is less than 1 meter. So you have like a high between two consecutive high tides. We want to find out when or how long the water is under 1 meter. So like let's say that this is where 1 meter of height is. The time that it's under 1 meter would be this length of time here. From here to here. So we are going to find out when the tide is 1 meter, and then when's the next time it's 1 meter, and then we just subtract the two. Okay, so that's a GDC calculator, right? We're gonna just type in this function. We're gonna type in y equals 1, and then we can find their intersection. So let's just do that. Here's Desmos. Let me just okay. Oy. So currently, let's call this y equals 1.63 sine 0.513 bracket x minus 8.2 bracket bracket plus 2.13. So here is our sine wave. And then we're just going to find its intersection with a y value of 1. And then there you go. So we have one time, I'll just write it here, b. So we have 3.569 hours to 6.707 hours. This is when it's below 1 meter. So in other words, we're going to subtract and then you get 3.14. Okay. Then we need to find the rate of change of the height of water when t equals 13. So that's really easy. The rate of change, you should recognize that this is just the derivative. So we're going to take the derivative when time is 13. And you can just do this in your graphing calculator. Every graphing calculator should have a derivative button somewhere. Like right here is nderiv. Even Desmos has it. So if we go back to Desmos, if I call this like f, for example, then I can calculate f prime at specific values of my variable. So in this case, 13. So you can see this is the value of the derivative. It's negative 0.651. And then I guess you need meters per hour, which this is fine. Because I think the units are meters and hours, right? Yeah. Okay, easy peasy. And then this looks like... yeah, we have a second island which has its own equation for the height of water. And we need to find ABCD. And they're going to tell you the low tide and the high tide. So you can sketch this out. So it says low tide is 0.4 meters. They say high tide is 2.74 meters. the low tide occurs at 2:41, and then the high tide occurs at 9:02. Oh, that's... Why are they annoying about that? Okay, we need to convert both of these times into full hours. So 41 minutes is going to be divided by 60. And then if we add that to 2.68. Let me just try not to overlap with the question. Hello? Okay, and then same thing, 9:02, 2 minutes, so 2 divided by 60 plus 9 is 9.03. Okay, low tide, high tide. It's kind of ugly, but whatever. Okay, so here's your wave, and then there's like three properties about waves. There's the amplitude, the period, the midline or the center line, that will tell us about the coefficients of your equation. First off, I always like to find the middle center line. And the center line is always in between the maximum and the minimum. So what we can do is to find that value, we take their average. So if we add them together and divide by 2, this should give us the value in between. So 2.7 plus 0.4 divided by 2, 1.55. And what's nice about the midline is that this is the value of D, because a sine graph and a cosine graph, normally the center line, the midline, is on the x-axis, and D is vertical displacement. So the only way for your midline to be anywhere else but on the x-axis is if you moved it up and down. So this number is exactly how much you moved it up. In a very similar fashion, we know what A will be. A is related to the amplitude. So we're going to find the amplitude. There's lots of ways to do it. If you have the midline, right, then you can just like subtract these two or subtract these two. You can also take the maximum and the minimum. If you subtract these two, then that's the distance from the minimum to the maximum. And then that's double the amplitude, and then you can divide that by 2. And it doesn't matter how you do this. So I'm just gonna do, I'm gonna say amplitude is, what would I rather subtract? I'm gonna do 1.55 minus 0.4. So I'm finding this distance here. So this is 1.51. And then this is the absolute value of A. What I mean by that is this is like what the actual digit is, what the number is. But A could also be negative. And that will depend on later in the question what they want. Or actually, I just didn't read the full question. If you notice, it does say that A has to be a positive value. So never mind. This is the actual value of A. And I usually say like D for mid line, and then A is amplitude, kind of obviously. Okay, the next thing is B. So I'm gonna write it up here. Let's use purple. Okay, so you know that the period is 2 pi compressed by B divided by B, which means that we can also calculate B if we know what the period is, because we just switch these two values here. So B is 2 pi divided by P, and we kind of know what the period is because I do know the time it takes to go from the low point, the low tide, to the high tide, and again this is half of the period, right? So we're gonna take 0.9.003, and then we're gonna subtract the 2.68, and then you see it will take 6.35 hours to go from low to high. And what this means is your full period is double this, so 12.7. So now I know that this is 12.7 hours. So my period is going to, or rather my B value is going to be 2 pi divided by 12.7. Okay. I guess I'll calculate it. 2 pi divided by 12.7. So 495. Okay. Now, like I said, A for amplitude, easy. D for mid line. B, this is what I tell my class. I used to tell my class, it's really stupid, but I called it period. It's not quite period, which is a very common mistake. People think they see the value of B, and then they think that this is the period. It's the period. So it's related to period, but it's not quite the period. They're related through this relationship here, right? 2 pi divided by one of them is the other one. Okay, and then the last thing you need is the C value, which is the phase shift. The problem with phase shift, though, is that it usually depends on what the question wants from you. So for example, in this question, A has to be positive. The function is also specifically sine. So if we were to graph this equation the way it is, so with our A, B, and D values, so let me pull out Desmos again. Or actually, let me use... Okay, let's graph this other island. I'm gonna just steal this. I'm gonna paste. And then we're gonna change the values to what we figured, what we had. So A was 1.51. So 1.51. I guess I'll call it G. Let's see. B was 495. We do not have a phase shift currently, so I'm gonna call it C, and then I'm gonna set C to 0. And then I don't need F right now. And then D I said was 1.55. Okay. So let's take a look at what you currently have. This is the wave as it is without the phase shift. Notice my high tide is in the wrong place. My high tide is happening at 3.1 and I need it at 9.03. right? My low tide is in the negatives, or it's over here. Now notice the way that we have our sketch. The low tide happens first after midnight, which is the origin, and then it's the high tide. So all that means is that we need to either move our graph to the left like this, or we need to move it to the right. Now, what does it say? It says right here also, right, that C is positive. In other words, combined with this, it says that you have to move it to the right. So I need to take this, which is without a phase shift, and move it to the right until my high tide is going to be at whatever it said, 9 point something. So how do I find out the exact value of that? Basically, I need to find out when this low tide, the one that happened before midnight, the time that that happens, and then that needs to be moved to the time that I want. And I know that this says like that's the time, so you can do that easily. You can, you know, in your graphing display calculator GC, you can graph this without a C value, and then you can find the minimum value here. Another way that you can do it is you do know okay, this is gonna get a little messy. So because of how symmetric waves are, oh my god, this diagram's gonna get very colorful. Let's see. Let's do light gray. The distance between the low tide and the water being at center line, this is a quarter of your period. So what you can do is you can divide your period by 4, or you can take half of your period and divide it by 2. So I know that this distance, or this time length, is 3.175. So what that means is that before my phase shift, right, this is a positive sine graph, so we start on the center line, and then you go up and then you go down, which means that on the other side you go down and then you go up. That means that I know that this minimum happens at negative 3.175. And what I want to do is I want to do a phase shift and move this to, what was it, like 2 point something? 2.68. I want to move this minimum, this low tide, so that it happens here, the way that the question wants it to. And then you can just calculate, right, what's this phase shift to go from here to here, which is like 5.855. Let's just say 5.86 maybe. I'm trying to do this in my head, but you just add these together, right? Well, subtract these, which technically means that you just add these values. So those are your two options. You can either just do a GDC, right? And then find this minimum. And then we want to move it to 2.64. So you see, about 5.8. So this is C, phase shift. Okay, how long is this question? 16. Shit, I've been talking about this question for way too long. And then what's the last one? We want to find out when both the things are the same height for the first time. Okay, so 5.86 is C. I'll just leave it like this for now. 5.86. Okay, here are the waters, right? And then we just want to find the first time that they're the same height. So in your GDC, you now have both these equations. So graph them, use the intersection function finding thing, and then right there, 4.47 should be the value of t. Holy, I'm like 10 minutes overtime on this question. Oh well. That just means that I'll have to do the HL level ones faster. Okay, what do we got? We got a curve. It's symmetric. Here, it's got horizontal tangents at P and Q. Then we need to show this is the derivative. Okay, so this is an implicit differentiation because you have X and Y kind of mixed together in one statement, in one equation. So that's what we're gonna do. We take the derivative of both sides. And so on the left side, the derivative of E is itself. Then we chain rule and we multiply by the derivative of X plus Y. So that's 1 plus Y prime, the derivative of Y. Then on the other side, we can do the exponent rule. So 2x plus 2y, and then this needs to be chain ruled with a y prime. Okay. And then once you've implicitly differentiated like this, we're going to solve for y prime like a variable. So we got to distribute the ex plus y in, and then I'm going to then take this term and move it here, and then I'm going to take this term with the y prime, I'm going to move it over here. So I'm collecting my y primes together. So I'm going to have ex plus y, y prime minus 2y, y prime equals 2x minus e to the power of x plus y. And then these we can just factor out the y prime. And then we're basically done. Right, we just need to divide this over here, and then we would get this. Okay. Next up, we need to show the coordinates PQ satisfy this equation. So the only thing we know about PQ is that their tangents are horizontal. In other words, the derivative is 0 here. So that's what we're going to do. We're going to set our derivative equal to 0. So if I make this equal to 0, and then if I multiply the denominator over, then that just goes away. So what I'm basically left with is this equation. 2x minus e x plus y equals 0. Okay, now I need to somehow turn this into this. And the first thing is, okay, there's no e and there's no y. So is there a way to make a substitution? To make a substitution, I need to use another equation, and I only really have this equation right here. So that's fine. We're going to substitute exy with x squared plus y squared. So this becomes minus x squared minus y squared. Okay, that's looking pretty good. And then I also do not have any y's. So I need to solve for y in terms of x. And I realistically only can do either this one, but I don't think you can solve for y like that. Or this one. This one looks good. Okay. So we got to use this twice. So from here, right, this is saying that ex plus y is equal to 2x. In other words, the natural log of 2x is x plus y. So y is natural log 2x minus x. Okay, and then this can be substituted in here, and I think, yeah, if we expand this out, if we square this, you'll get here. After you like collect like terms or whatever. Nice. Okay, next up, using the line of symmetry, oh wait, no, hence find the coordinates of P and Q. Okay, so hence means that we are gonna solve this equation here. They give you the equation for a reason. We need to find out x. Okay, that's pretty straightforward because this is a calculator question. You can just literally type in this equation into your equation solver and then find out what x is. So that's what Wolfram Alpha is for instead of my GDC. So we have what? 2x to the power of 2 plus natural log 2x. All of this is squared minus 2x times natural log of 2x minus 2x equals 0. And I don't think I need to tell it to solve, but I'll just say solve. Okay, and then here are your two solutions, 0.33 and then 1.84. Of course, P has the smaller x value, Q is the larger one. So let's just write that down. This is BII. So P has an x coordinate of 0.331. Q has an x coordinate of 0.8184. Okay, and then we need to find their y values. So the way that they are, and then we can just use this. Yeah. Now there is one little, you can't always do this though. So the way that x and y are related is actually through this function. However, I can use this equation. I can use this equation to calculate y because this equation specifically came from information about P and Q. P and Q will always have this equation as true. This means that they're horizontal, their tangents are horizontal. So I can use this equation to calculate y specifically for P and Q. Like if I gave you another random x value, you would not be able to plug it in and get the y value. You'd have to plug it into here for x and then use like an equation solver again to solve for y. But okay, plug those things in. Natural log is right here, 2, And then x is 0.331 minus x is 0.331. So I got negative 743 as a decimal. Same thing we repeat with q, natural log. 2 times 1.84 minus 1.84. So negative 537. Yeah. Okay. Then, using this line of symmetry, write down the coordinates of the points on curve C where the tangent is vertical. Okay, so the tangent is vertical here and here. And then these are basically the inverse coordinates of P and Q. Because we know that this is symmetric around y equals x. So you can almost think of this as like the inverse of this section. So all we do is we just swap the x and y coordinates to find P and Q. I'm not going to write it down, but you literally just switch these coordinates. Okay, next up, find the coordinates on the curve C where the tangent has, where C has a tangent, where C has a tangent with a gradient of -1. So if you look, right, having a tangent of -1, -1 slope is perpendicular to a slope of 1. So we're looking for a place where the tangent slope is perpendicular to this. There should be only realistically one location right here. And then this is the coordinate on this equation where y and x are the same. So we can do that. If you don't like just kind of eyeballing it like that, then what you would do is you would set the derivative dy dx to -1. And then this is what? 2x minus ex plus y over ex plus y minus 2y. So this multiplies here. You get negative e plus 2y equals 2x minus ex plus y. And then you land to the same conclusion, right? These cancel, and then so do these. So your coordinate needs to have y equal x. Just like what we saw from the quick diagram. Okay, so if that's the case, then for part D, I know that y equals x. So that means that my coordinate has to have this relation. So y plus x is the same as 2x now. And then x squared plus y squared is the same as 2x squared y. 2x squared. Okay, we need to find x. Nothing fancy here. We're just going to use an equation solver. So back to Wolfram. So e to the power of 2x is equal to 2x squared. And then solve. And here's your real solution, negative 0.451. So your coordinate is negative 0.451, and then we know that y is the same value. And then you're done. Okay. And then this should be the last one. Oh, big 13 marker. We got vectors. Okay, let's see. We got u and v, angle between them, using the definitions of u dot v, u cross v, in terms of the lengths and theta, show that this equation is true. Okay, this is actually a question that has shown up a few times, but u dot v, if you look in your formula booklet, by definition, is the length of u times the length of v times cosine of the angle in between them. So we're going to square that. We're going to add the magnitude of u cross v squared. So again, in your formula booklet, the magnitude of u cross v is calculated in this way, right? And then essentially, this is cosine squared. This is sine squared. So we know that these are 1. So all you're left with is, like, you would square the magnitudes, and then if you factor them out, you would get this. So now we've shown that this is true. Okay, then we have triangle ABC. These are the vertices. U and V are A, B, AC. Okay, so before I do anything else, let's calculate U. So the vector from A to B means that you take the coordinates or components of B and then you subtract the components of A. So this is going to be P minus 0, Q minus 1, and 3 minus 2. And the same thing for V. V is C minus A. So 3 minus 0, 2 minus 1, and then 1 minus 2. Okay, so now that that's out of the way, let's see. We know u dot v is 3, the area of triangle ABC is root 6, and then we want to find the value of the length of u cross v. Okay. So, if you do need kind of a visualization, A, B, like C, and then A to B was vector u, A to C is vector this. Okay, the magnitude of their cross product is the area of this parallelogram that gets made when you draw the vectors from, like, connecting their tails together. So this is, oh, and then this is triangle ABC, by the way. But like I said, this whole thing is the magnitude of u cross v. So if I know that the area of the triangle is 6, then that means that this should be twice as much. Or is it root 6? I think it's root 6. So this should be 2 root 6. Okay, so that's I done. Next up is hence or otherwise find the value of the magnitude of u. And then we are going to, now that we know this, and they told us this, we can use this formula and solve for the length of u. So now I know that the length of u, I'll write it up here. This is the square root of, what was it? U dot v squared plus the length of u dot, or xv cross v squared divided by the length of v squared. Okay, now I know this is 3, they told me. I just figured this is 2 root 6, and then this we need to figure out, but that's pretty easy. The length of v is going to be the square root of 3 squared, 1 squared, and 1 squared, so 9 plus 1, which is 11. And then now we can plug in all the values that we have. So we got 3 squared plus 2 root 6 squared over root 11 squared. Come on. Okay. And then if you do your math, the denominator is 11, and then this is 9. This is 4 times 6. 4 times 6 is 24, plus 9 is 33. And then 33 divided by 11 is 3. So this is root 3. Okay. Then, hence or otherwise, find the possible values of p, and then their corresponding values of q. Okay, so there are 2 variables, so we need 2 equations. One, we know that the length of u is now 3, so we can make an equation like that. Let's use green now. Okay. Where's my vector? Here it is. Okay, so if we square all these up and then if we add them up, that should be the same as the length squared. So in other words, here's equation 1. P squared plus q minus 1 squared plus, I think it's 1 squared. This should equal to 3. So this is our first equation. Yeah, 1 squared. And then we need a second equation. And for that, I know the dot product is 3. So in other words, if I dot these two, I should get 3. So that's our second equation. So 3p plus 1, okay. So here are my 2 equations, right? One from the dot product information and one from the magnitude or length of u. And then we can solve this using substitution. Let's see. I'm going to say q minus 1 from this one. This is the same as 4 minus 3p. And you can solve for q as well. But because this whole thing is q minus 1, then I can just solve for q minus 1 instead, and then I'll just put this in here. Okay, so now that I put that into here, then I'm going to get p squared plus 4 minus 3p squared plus 1 equals 3. And then you can solve this. You can use an equation solver. It's a quadratic, so maybe you don't have to. Let's see. P squared plus 16 minus 24p plus 9p squared. And then this is minus 2 equals 0. In other words, we got 10p squared minus 24p plus 14 equals 0. We can divide everything by 2. So you got 5p minus 6p plus 7 equals 0. And then this is looking factorable. 5p, p, and then 1 and 7. So where does 1 go and where does 7 go? Wait, Oops, I divided this by 2. 24, 12. Okay, 12 is 7 plus 5, so that means that the 7 goes with the 5, the 1 goes with the p, and then these are both minus. So we got two values. P is 1, or 7 over 5. And then we need to find their corresponding Q values. So for that, I'm going to use the here, right? So I guess I needed to solve for Q eventually. So this is 5 minus 3p instead. So that means that if P is 1, Q is 2. And then if Q is, or if P is 7 over 5, okay. What's 25 minus 21? 4. So this is 4 over 5. A little bit of fraction math. Hopefully that's right. But done. And then let's see, what's next? Consider a new point, D. W is C to D. It is given that U.W and V.W is 0. The area of the triangle ACD is 5. And then assuming P is 1, so we're using this one, find the possible vectors for W. Okay, so if you look at this, this is saying that V is perpendicular to both U and V, right? If your dot product is 0, it means that your two vectors are perpendicular. So here, let's draw this so that you can visualize it. So here's A, here's B, and then I'll just put C here. Doesn't really matter. So this is U, and then this is V, right? And then any two vectors will lie in a plane together. So imagine these guys are contained in this flat plane. Now, we know that W, which I think is CD, so there's a point D. The vector from C to D needs to be perpendicular to both U and V. In other words, W is perpendicular to the plane. So, like D could be up here. So this is W. Notice, right? It's perpendicular to the plane. They said possible ones because you don't know whether D is pointing in the way that I oriented it and drew it, up or down. So D could also be like D could have been below the plane and it could be pointing down. So we need to figure that out. Okay. That means that I know, don't forget that U cross V gives you a perpendicular vector, right? So U cross V and W are more or less going in the same direction. In other words, W is a scalar multiple of U cross V. So first we should find out what U cross V is to find the general direction of W, and then we'll find the scalar because we do know, we can find out how the size from this information here. Okay, U cross V. I hate taking cross products, this sucks. Okay, what is U? 1? And then it's Q minus 1, so 1. I think this is -1. And then this is V, right? V is like 3, 2, -1. Why am I even bothering? Let's just look. 1, Q is 2. So 1, 2 minus 1 is 1. 1 again. And then 3, 1, minus 1. So this is all 1s. This one is 1 minus 1. Okay, and then we cross. I'm trying to stay under an hour, but I don't think I'll make it. Okay, I never remember off the top of my head the stupid formula for cross product. But I think it goes this one minus this one first. Like those two times together minus the other two times together. So we have 1 times negative 1, which is negative 1, minus 1 times 1. So it's that one. And then it is, for the second component, I think it's this one. Is it this one times this one? Minus this one times this one? 50-50 chance. Okay. Time to Google IB math formula booklet. Alright. Stupid cross product calculating. V3. Okay. So we're doing the ones I circled first, and then they are going to be subtracted from the other ones. So 3 times 1 is 3. Minus 1 times negative 1, so this is plus 1. And then the last one... The last one is this one times this one minus this one times this one. So 1 minus 3. Okay, so our cross product is negative 2, 4, and negative 2. Let's just find the direction. We don't really need the multiple of 2 because that's going to change anyways. Okay. I hope that that's right. I know the process is right. Maybe the little math mistakes here and there might be wrong. Okay, so this is U cross V. Now, if you notice, right, so if this is U cross V, we can calculate the length of U cross V. And this is 1, well, square root. 1 plus 4 plus 1, so this is square root 6, right? Oh, we already know it's square root 6. They told us earlier. Right here. Or, well, okay, it's not technically U cross V, but you know what I mean. U cross V is this one, which is why it should have been 2 root 6, but we'll just say this instead. Alright, as you can see, this is root 6. We need to find out how long W should be. And we know ACD is 5 square units. So ACD is... Okay, now this is going to get really messy. ACD is this triangle, right? And we're going to do the same concept. So triangle ACD is 5. This means that W cross with vector v, this one down at the bottom, is 10. In other words, the length of w should be the square root of v dot w squared plus the length of, I guess it'll be w cross v squared over the length of v squared. Now, we know a lot of these things. For example, we know that this is 0, they told us. 0. We know that this is 10. So this is 100 over, I think it was 11, right? Okay. So as you can see, this is too short. It's in the right direction, but it's too short. So W is longer. What that means is that W, right? No, I'm like 2 minutes over 1 hour. So W is in the same direction as U cross V, but first we create a unit vector. So we're going to divide this by root 6. So now it's a length of 1. And then we multiply it by the length that we do want it to be, which is 100 over 11. And then you can clean this up, but then we're basically done, right? So in other words, W should be, this is root 100 over 66. That's 50 over 33. I don't know, whatever. I don't know what they want from you, to be honest, answer-wise, in terms of format. Do they want it rationalized, reduced, and rationalized? But I'm calling it done. We're done. Something like this. That's W. Okay. Not bad. I spent the most time on the SL level question. But that's it. That was M23 HL analysis and approaches for time zone C Americas. Not bad. If I were to give my opinion, this set of exams, like paper 1, 2, and 3, is not that difficult. I think there's obviously going to be a few tricky questions, but overall, like, these are pretty standard questions. Like, you can find a lot of these questions in textbooks, Revision Village, practice exams, question banks, former paper questions, even from older curriculums, because the curriculum is not that much different. So yeah, honestly, not the hardest group of exams. And then, oh yeah, and then, by the way, the reason why this was wrong in the short answer, paper 2, and I couldn't quite get the 80, I couldn't quite get it to show that this is 86, is because I put in 90 here instead of 80. So all of this is, the process is right, but all the numbers are wrong. So listen to what I say and put in the right numbers. Okay, thank you for watching, you guys. I'm going to go through SL, but only the questions that I haven't done. So they will be short videos. Okay, see you guys later.